Today we're learning about bar graphs. Please copy down the standard benchmark indicator on the next clean page in your math notebook. The student, given a problem situation, will collect, analyze, display, and interpret data in a variety of graphical methods, such as a bar graph. You can pause the video here to give yourself time to write down the SBI. Scales and bar graphs. A bar graph is a way to visually display and compare numerical data. The scale of a bar graph is the ruler that marks the height of the bars. The intervals are the equal divisions marked on the scale to make it easier to read. The lines on which a bar graph are built are the horizontal axis, that's going from left to right, and the vertical axis, which goes up and down. The range of a data set refers to the difference between the highest and lowest value. Looking at our example, Sam followed these steps to make a bar graph using data on mountain heights. Step 1. He used a scale from 0 to 30,000 since the highest mountain was 29,000 feet. The range of the data is 15,000. He used intervals of 5,000 because 30,000 is divisible by 5,000. So if you look on the vertical axis, the up and down bar, you can see he goes from 0 to 30,000, and each time he goes up a line, which are evenly spaced apart, he goes up by 5,000. It's the same interval every time. Then, for step 2, he drew bars to represent the data and labeled the bars. So you can see each of the mountain bars drawn in there, and you can see they're each labeled by the name of the mountain, and then he tells you at the bottom that they're mountains. On the vertical axis, he tells us it's the height to the nearest 1,000 feet. So we know right there that the mountain heights have been rounded to the nearest 1,000 feet. And then finally, he wrote a title on the graph. He titled it Mountain Heights, so we know what he's talking about. For the try it, we need to use the data to complete the bar graph. Ocean depths to the nearest 1,000 meters. So we have our 4 oceans listed, and it tells us the depth of each one. So the Arctic goes to about 6,000 meters, the Indian to 7,000, the Atlantic to 9,000, and the Pacific to 11,000. So the first thing we have to figure out is A, what is the range of the data? So we're going to take the highest number minus the smallest number. So we get 11,000 minus 6,000 gets us 5,000 meters. Next, for B, what interval is used on the vertical scale? We look over at the scale there. We can see each time they hop to the next line, they've gone up by 2,000. So the interval we're using is 2,000 meters. Next, C, would it be reasonable to use an interval of 20,000? Explain. It would not be reasonable to use an interval of 20,000 because all of the data points are significantly less than 20,000. Next, we're going to draw the bars that represent the depths of the Indian, Pacific, and Atlantic Oceans. So the first one we're going to do is the Indian, which goes up to 7,000 meters. So when we draw our bar, it's going to go halfway between the 6 and the 8,000 on the graph. Next, we're going to add the Atlantic Ocean, which goes up to 9,000 meters. So it's going to go halfway between the 8 and the 10,000. Finally, we're going to add the Pacific Ocean, which goes up to 11,000. So it's going to go halfway between 10 and 12,000. Finally, for step E, we need to give the graph a title. And the easiest one to do right here is just ocean depth, just like our chart is titled on the left. Finally, for step F, write a problem that can be solved using the data in the graph. Once you've done that and you've made sure your entire worksheet is completed, please glue it in your math notebook.